Hi guys, what's up and welcome to a new mathematics video. It's me, Mr. Moustache Mathematics here, aka Mr. Stringer. Today we're going to be looking at a revision pass paper. It's specifically for my year 10 group who are studying for their end of year exams. Now, it's a Unit 3 paper, so it's just focused on Unit 3. To anyone else watching this video, it still is a higher tier paper, so it might be worth watching. It's completely up to you. Now, it's a calculator paper, that's worth noting, so I'm going to get my calculator here at the ready. And now, if I move that to there, I think that's in the screen recording. So, write your name here. That pen is horrible. Let's try a little bit of a blue. Stringer. Okay, so 1 hour 45. What things can we have? We can have compasses. Yep, all good. Use the pi button. 80 marks. Hopefully we get all 80. Fingers crossed. We'll use a black pen just because they say please use black ink. So things worth noting, right? The formula page. This is for the higher tier, so of course it's going to be a little bit different to the foundation paper. Volume of a prism. So that's any prism, so that means it's got anything where it's got a constant cross section throughout, so that means the front face and the back face are exactly the same, and if you was to drag the back face or the front face all the way from end to end, that it will be constant throughout. It's not like a let's say for example, what we got here, that's not a constant cross section, definitely not, got some weird dent in it. Now, so volume of a prism, that might be useful. Volume of a sphere and surface area of a sphere, worth noting. For trigonometry down here, we've got the quadratic equation for solving quadratics. Volume and curved surface area of a cone and area of a trapezium. So a few things just to quickly familiarise yourself with. Might be using those. Answer all the questions. Write your answers and write down. You must highlight. You must. Write down all stages in your working. Work out the reciprocal of 1.25. Finding the reciprocal of pretty much any number is essentially inverting it, flipping it if you like. If you recall that any number is technically divided by 1, but we just don't really write that. If we are to flip this, this will be 1 over 1.25, which is 1 over 1 1/4, which is 1 over, technically 1 divided by 5/4, which is actually 4/5. I think any of these answers will be acceptable, but if you didn't know, so if we were to do 1 divided by 1.25, which is actually 1 over 1.25, it is 4/5, as we can see here. But any of those will be acceptable. They're all reciprocals. 1 over 1.25, 1 over 1 1/4, 1 over 5/4, or 4 over 5. They're all acceptable. And for those of you who didn't know, this button here, x to the power of -1, that's the reciprocal button. Put a number in, finding the reciprocal of it, 4/5. That goes for anything. That could be something as simple as 5/4, and then put that to the -1, that should flip it or invert it if you like. That's the reciprocal button, worth noting. Easy 1 mark, so we'll take 4/5 as our answer there. Work out the value of 9.6 divided by square root of 5, subtract 1.7. Be very careful. I can already spot the mistake what people make here. They will do this. They will not exclude the square root there. They will include the subtract 1.7 within that, and you can see that's definitely not there. So definitely do not do that. So easy 2 marks. First things first, 9.6 divided by the square root of 5. Press right on the calculator to move out of the square root. Subtract 1.7. 17.90817,658. Could I just be cheeky and print screen that rather than writing it out? Does that work? Doesn't work. Right, not that technological. 17.9081. 17.9081. 7658. Yes, I'm writing out the whole number because it's a 2 mark question. 1 mark for writing out the correct answer, so the unrounded version. And I will then get my second mark because it says give your answer correct or 2 decimal places. There's 2 decimal places. Look to the right. The 8 will round up the 0. 17.91. That's my rounded answer. So essentially 1 mark there and 1 mark there. 2 in total. So it's looking good. 3 marks so far. Going back to the black pen. No idea why I changed to the blue. Matches are sold in 3 sizes of the box. Small box contains 52 matches and costs 23p. You get quite a few matches there for a small amount of money. Medium box, you get 170 matches and costs 72p. A large box contains 960 matches and costs £4.16. This chair's so squeaky. Let's just moved apartment, so everything's a little bit, yeah, weird chair. Which size of box is the best value for money? Right, so you've got 3 boxes. It'd be good if we could just say what 1 match costs for the first box, what 1 match costs for the second box, and what 1 match costs for the third box. And then you can just compare the prices. So it's just as simple as sort of setting out 3 separate prices like this. I would say that 52 matches, it costs 23p. I'd say that 170 matches costs 72p, and 960 matches costs £4.16. Let's find out what 1 costs. This is the unitary method, so we want to scale this down to 1 match. If you've got a number, you want to get it down to 1, you divide it by itself. What you do to one side of the equation, you must do to the other, because it's balanced, right? Divide by 170. So that will get 1 match there. Divide that side by 170, and then divide this by 960 to get that down to 1 match, so we can compare all 3. Divide by 960. Right, so I'll just do 1 at a time. 23p, 0.23, divided by 52 equals 23 over 5,200. Oh god, that's a very small number. Yes, very, very small. 4.42307 times 10 to the minus 3. Let's go for that. 4.42307. 4.42307 times 10 to the minus 3. For those of you who don't know, that means 4.42307. When it says 10 times 10 to the minus 3, it means move the decimal place back 1, 2, 3 times. If you move it back past the 4 once, it'll be 0.442307. Move it back again, it'll be 0.044307. And move it back one more time, it'll be 0.00442307, etc., etc. So either or, just compare it like that. 0.72 divided by 170. Sorry, I'm trying to be fast, got things to do. 4.235. And that one on the left, we said, I'll put that to 5 decimal places, do the same here. 4.23529. 4.23529. Move out of the way, that was a bad idea. 4.23529. I can't concentrate. 4.23529. 4.23529. Times 10 to the minus 3. So instantly, just looking at the one on the left and the one on the right, they're both times 10 to the power of minus 3, so that means they both move back exactly the same amount of decimal places. That means you can compare them exactly as they stand. Now currently, 4.23529 is smaller, right? This one is smaller than 4.42307. So that one's currently bigger on the left, this one's a smaller one. I can really ignore this one now, I don't really need that, because this one currently is saying you can get 1 match for a little bit cheaper than the one on the left. Just got to look at the one on the right now. 4.16 divided by 960. 4.16 divided by 960. We get an answer of something times 10 to the minus 3. Yeah, all of them. 4.3 recurring. Don't have to remember that one. 4.3 recurring. Da 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 da. No, you don't do that. Don't know why I did that. You either put it above 1.3, so that's 4.33333333, or 4.3 recurring. You don't put it above all 3 because that'd just be stupid, etc. So da 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 times 10 to the minus 3. Now that one's 4.3, which is actually still bigger than the middle one. So actually, yes, this is the small, not the smaller, it's the smallest. I.e., it's the cheapest value for 1 match. So we want to go with the, what is it, small, medium, large. We want to go with the medium. Malcolm in the middle. So, which size of box is the best value for money? Tick. Show how you got your answer. Well, just showed it. The diagram shows 2 rectangles. Diagram not drawn accurately. Yes, some of you might be surprised about that, but this 120, that there, that tiny thing, that's not 1.2 meters long. Diagram not drawn accurately. Yes. The rectangles are similar. Right, first thing, that means that if you are to get a rectangle and a larger rectangle or a smaller rectangle, if they're similar, it means that they're increasing by the same proportion. So if you are to stretch one side by 4, it means you must stretch all sides by 4. If you are to stretch one side by 2, you stretch all sides by 2. If you're meant to half one side, you half all sides. So it means that if this side is similar to this, when it gets scaled up, obviously you're multiplying by 4 there, or if you don't know, you can just do 120 divided by 30, get an answer of 4 on the calculator. That's how many 30s go in. That's what it's being times by. Someone might get confused that this is a rectangle, and that means that if this side is W, this side is W, because this bit's on the right, so this bit should be on the right. Maybe that's something someone was thinking. So if that's W and that's 84, we can then sort of work backwards. So if we're going from the small to the big one here, you're timesing by 4. If you're going from the big one to the small one, we need to divide by 4. So 84 divided by 4, potentially getting a method mark here. Is it worth 2? Yeah, or 1 for writing that down. Or 1 for finding the scale factor, whether that be timesing by 4 or dividing by 4. And then 1 just for getting the answer. 84 divided by 4, 21. Why has it gone back to blue? 84 divided by 4, 21. Yes, I can do maths. God. Work out the value of W. Well, W equals. That makes someone happy. Tony buys and sells cars. He has to reach a target of at least 40% profit. So whatever he bought it for, he needs to make at least 40% profit. Or potentially he's a bad salesman. Because he bought the car, then he needs to sell it on for cheaper. So yes, he is a salesman. But he buys and sells cars, so he owns the business. That's irrelevant. Okay, so he needs to make 40% profit. On Monday, Tony buys a car for £1,500. Buys it for £1,500. What is 40%? Because we need at least this amount of 1,500. 40% of means multiply of 1,500. 150, 600. Is it 600? Yes. Right. So £600. Tony boy, you better be making that amount, else you are not a good salesman. So that's how much he bought the car for, 1,500. He needs to make that amount, right? At least of profit. Pure 100%. I can't spell profit, or should we go for actually profit? That would make more sense. Pretend it's profit. On Tuesday, Tony sells the car for 2,150. Well, what's the difference between the two numbers? 2,150 subtract 1,500. This is the actual profit, right? Just to emphasise that, it's put in capital letters. This is the profit he made. For those of you who do not know what 2,150 subtract 1,500 is, I will convince you that it is 650. Yes, right, 650. So 650. That's how much profit he actually made, and he needed to make at least £600. Tony made enough profit to reach his target. Target, probably wouldn't write it like italic sideways in an exam, but I'm learning on OneNote. Yeah, so we just showed it. So he made actually £50 more than the minimum. You could say that if you'd like. 3 marks there. I'm guessing 1 mark for calculating the expected minimum profit, 1 mark for calculating the actual profit he made, and 1 mark for making a decision. I can't say that, I haven't looked at the mark scheme, so that's not definitely true, but it's just worth noting that's how it possibly could unfold. It's always nice to think about where you could get your marks. The diagram shows a scale drawing of a garden. 1 centimetre represents 2 metres in real life. So 1 centimetre on the page is 2 metres in real life. Harvey, is that Harvey or Harvey, is going to plant a tree in the garden. The tree must be less than 7 metres from the fountain. Now, unfortunately, I do not have a... what's the item called which I need? The object. It is called a compass. Right, so the compass, at this point, it says the tree must be less than 7 metres from the fountain. So you've got your fountain, right? It needs to be less than 7 metres. Well, just to give you a quick sketch, pretend that this pink pen, that is a 7... Oh my god, that is so skinny. Not a good look. Alright, so you're not going to let me change the thickness? Thank you very much. That's really not that much better. So pretend that's 7 meters. That line there, so if you was to stretch your compass 7 meters, you could then, if that was then representing 7 meters. Of course, the issue is with the compass, you're never stretching your compass 7 meters. And you just need to bear in mind the following in order to know how far to stretch it out. Look at the scale. 1 cm equals 2 meters. We want to get it to 7 meters. So we need to find out what we need to times 2 by to get to 7. Some of you might be like, it's easy, it's 3.5. Some of you might be like, I've got no idea. How many? 2 is going to 7. 3.5. Times it by 3.5. Times the other side by 3.5. Remember, anything you multiply, when you're multiplying 1 by anything, it's just itself. We need a 3.5 centimetre line to represent 7 meters. So let's pretend this is 3.5 centimeters. Actually, I think that could be around 3.5 centimeters. Now, of course, stretch your compass 3.5 centimeters and then spin it round. Actually, do you know what? I'll just illustrate it by just doing it a little bit larger here. Spin it round like that. Oh my god, that's such a perfect circle. Do you know what? Watch my perfect circle. Yeah, ignore that. We'll stick with the first one. Okay, so there's my perfect, absolutely perfect 7 meter radii circle. So that basically means that any point from the centre to the edge is 7 meters away. Brilliant. And then the other one, the tree must be, that's from the fountain here, 12 meters less than the bench. All right, so 12 meters, let's see what that is. 1 centimeter equals 2 meters. Oh, that's easy to get that down to 12. You've got to times it by 6. Or you could do 12 divided by 2 on the calculator. Times 6. So we want a 6 centimeter line as opposed to a 3.5. So it's about double this original one. So let's pretend it's something like, I don't know, probably that. There can be our 12 meter. We draw perfect circle in. Now what to say? On the diagram, show by shading the region in which Harvey can plant his tree. Because it has to be less than 7 meters from the fountain and less than 12 meters from the bench. It's got to be less than 7. It's got to be less than 7 from the fountain and less than 12 from the bench. So what you couldn't do, you couldn't pick a point here because that's not less than 12 meters from the bench. Although it's less than 7 meters from the fountain, it's not less than 12 meters from the bench. What you're looking for is this little region here, this overlap. This overlap's very special because if you think about it, if I am to pick, can we do orange? Orange? Orange, please work. Yes. If you pick this point, that point is less than 12 meters from the bench because it's not quite at the edge of the circle, thinking about the circle, 12 meters all the way around. And it's also, it's less than 7 meters from the fountain. So that's your region where he can plant his tree if he so wished. Any point in there. Of course, you need to do it accurately, unlike me. Still award myself 3 marks there because unfortunately OneNote does not have a tool yet, which is compass. Right, 6. Diagram shows a prism. Oh, formula page. Diagram not drawn accurately. Okay, so all corners are right angles. So every single corner here is a right angle. So we can assume that if we was to maybe make that along like that, that actual whole shape would be a square. And then if we were to punch out, so if we was to take away this section here, we could say that's a square, subtract a rectangle. Might be a square, might be a rectangle. We'll have a look, just have a check of the dimensions. This length is 7 and that length is 5. So yeah, it's a rectangle, the black shape there, that's a rectangle. And is this one a square? That's a 3, that's a 2. No, they're both rectangles. So if we work out the volume or the area of the black rectangle and then subtract the area of the pink rectangle, we will be left with this area here, which is sort of what we're after. So you could go about this one of 2 ways. You could work out the volume of, essentially, if I show you, if we work out the volume of this object, got my 3D drawing, terrible, 5, 7, 9, and then we work out the volume of this. So that one is going to be this part, and then if we work out the volume of this, we subtract it, so that little one, little section. There's many ways you can tackle this. It's not, oh my god, that's so bad. This is not the only one. 2, 3, and 9. You will be left with what we want, which is this funky looking sideways C, some could say. Something like that, along those lines. Anyway, I am no Van Gogh. So, let's work out the volume of a prism. It says on the formula page, work out the area of the cross section, which is the front of the shape, and then times it by sort of the stretch, as you like, or the depth. So the area of this front shape, this is simply a rectangle, 7 times 5 to work out the area of a rectangle, and then times it by this stretch, which is 9. That's the volume of that shape. This one here, work out the area of this rectangle. We need to do 3 times 2 to work out that, and times it by the stretch, or the depth if you like, and that will give us what we're after. So you could calculate them separately and subtract them. I, however, will put them all on one line. 7 times 5, you don't need to put the brackets, but I'd like to. Makes it clearer to me. 3 times 2 times 9 equals 261. What's my units? Centimetre, 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 all over the place. 3 of them, because it's volume, length, width, and depth. Centimetre cubed. Hasn't got units on this question. Sometimes you find there's units here sitting on the answer. So 4 marks, it could actually be 1 mark, 1 mark, 1 mark, and 1 mark. Now, you've got a few things you could have done here. You could have initially split the shape into a rectangle like this, worked out that one. This rectangle, worked out that one. This rectangle, worked out that one. So it's 3 separate prisms, and then added them together. You could have split it horizontally. There's probably 1,000 ways you could have done it. You could have worked out the area of the first face, 7 times 5, subtracted it from 3 times, and then subtracted 3 times 2 away from it. So 35, subtract 3 times 2, 35 subtract 6, which is 29, and then done 29 times the depth, which is 9, which is 261. Alright, 29 times 9. Yeah, 7 times 5 is 35, subtract 6, which is 29. 29 times 9. 180 plus 81. Yeah, so you could have done that. You could have worked out the area of the, like I say, and the area of the black rectangle, subtracted the area of the pink rectangle, and then just times it by 9, which is essentially what has happened here if you were to factorise it. So there was a few methods there, as long as you're reaching the answer of 261. Now question 7, reflect shape A in the line x equals -1. Really quite straightforward. It's an x line, and only an x line's got nothing to do with y. It crosses the x-axis at -1, as it literally says. There's your mirror line. Now that is 1, 2 across, so I'm going to go 1, 2, that's that corner. This one is 1, 2, 3 and a half. 1, 2, 3 and a half. You're there. Just to check, this diagonal line is going along 1.5 up 2 from here, along 1.5 up 2. That's definitely there. So I can sketch that diagonal line in. This length is a half across and a hole. So a half across and a hole. That goes to there. And then this bottom bit is 1.5 in total length, or 1.5. Just in case of sketching these up. There we are. Reflected in the line x equals -1. It's a 2 mark question. You could get a mark if you was by accident to have reflected it horizontally, because you put the line as y equals -1, but you still created the correct reflection. So that's there. Fully describe, or describe fully, because that's actually the way the sentence is written. I'm not making my own one up. Describe fully the single transformation that maps shape P onto shape Q. Shape P onto shape Q. Here, very careful with the language. I mean that. Okay. Don't really know about that. Shape P onto shape Q. Right, so it's going from shape P to shape Q. It's going from small to big. It's enlarging. Even if it's going from shape Q to shape P, it's still enlarging, but it will be by a scale factor which is smaller than 1, but larger than 0. So describe fully the single transformation that takes P onto Q. So I'm going to put an arrow like that just because it forces me to think it's going from little to large. All I need to do is just say, well, first things first, you've got 4 types of transformations. You've got rotations, you've got translations, just picking it up and moving it. You've got reflections, then you've got enlargements. This is the easiest one to identify in my opinion. Enlargement, 1 mark, because I've said one thing. I get 3 marks here. 1 mark for saying, what's it been enlarged by? So this diagonal line was a diagonal line, just 1 diagonal square. That's 1, 2. So it's gone from 1 to 2, it's doubled. Scale factor. Scale factor times 2. I'm going to check that on another line. This one here, this bottom line, that's a long 1. This is a long 2. That works too. That's from a half all the way up to the next half. That's 1 half. Doubled is 2. Yep, so scale factor 2. Last thing, you need to find out where it's been enlarged from. Sort of, as I was explaining to my class, when you enlarge things, it's sort of like being at a really old cinema where you've got like a light source, it hits the projector reel, and then it puts out the image onto the cinema screen. So the light source projects to hit the image, to hit the reel, which then produces the image afterwards. Where your light source is depends where your shape afterwards lands, so you need to find where was the centre. So in order to do this, you can do as follows. This is going to be a fail, I can tell. Match corner. Yep. How did I know you was going to do that? Right, match corner. So let's go there. I'll do my best. Oh my god, that's so bad. I'm clicking here. Right. Bear with me. I can do this. Ruler. This is going to be epic if it works. Match each of the corners up. You can call them a vertex if you like, if you want to be smart and sophisticated with your language. A vertex. Keep going all the way back. Match another one up. I'm going to go for this one. I'm going to see where these lines meet. I'm going to do another one. In fact, you could do all of them. Each of these lines which you're drawing are called rays, and the rays will all meet at one point, which we call the centre of enlargement. Okay, well this is a little bit easier to do by hand on paper, but I'm making it work. Oh god, go away. I think it was like that. I'm not touching it anymore. Right, so where they all meet, they're meeting here. Usually it's on the corner of the squares where they meet, so you actually get a whole, you get integer coordinates, i.e. you're going back 6, you're going up 2, you've got a coordinate minus 6, 2 here. It generally isn't halfway through a line, like you can make a judgment call. Is it minus 5.5? Is it minus 5.6? It's just where I've drawn it poorly, but that's where they'll meet. It's usually on the corner of a square. So centre of enlargement, I'd write that out fully generally, or about the point you could say, and then minus 6, 2. That's where it got enlarged from. 3 marks there. Next one, question A. It's got a star next to it. It's like question 2. A bit strange. So, Barack. Nasty. Barack is going to buy 550 nails. And they're like acrylic nails or nails you hammer in. Goodness, doesn't matter, does it? Alright, so you got Barack is going to buy 550 nails from either the nail company or the hammer company, because there's 2 of them. He wants to buy nails at the cheaper cost. Yep, don't we all? Where should he buy the nails from? 550 nails. Right, so you've got the nail company, you've got the hammer company. So nail company, hammer company wants 550. Right, so first of all, this one here, 50 nails, is £4.15 per 50 nails, but you've also got to pay VAT, because it says plus VAT at 20%. Now, if you think about it, if you've got 100% of the price and you're adding 20% on, in total you've got 120%. Just to reiterate that. I'm adding 20% on, so I've got 100% of my price and I'm adding 20% on the VAT here. So I want 120% of £4.15. The actual price you're paying is £4.98, so a little bit more than expected. £4.98 for 50 nails. 50 nails equals £4.98, right? We want to get 550 nails. 550 nails. So got to find out. We've got to times 50 by. I'm going to guess it's 11, but what do I know? Oh, it's 11. 11 lots of 50. Do exactly the same to the other side. So £4.98 times 11. It's that, which is this, £54.78p. We'll do the same for the other one. However, it's a little bit more tricky because it's 25 nails, £2.95. Right. Special offer though. Every 100 you get 25 free. So if you have 100, actually you've got 125. If you add 200 nails, you get another 25 free. So at that point, you would have 50 free nails so far. Because you got your first 25 for free at 100, another 25 free, so that'll be 50 in total. So now you've got 250, and then at 300 nails you would have got 3 lots of 25, 375, and then if you notice on the right, each time it's going up by 125, right, for every 100. So at 400 nails, you've actually got an extra 100 at this point. So when you buy 400 nails, you're actually getting 500 nails because of the additional 25 per 100. Now you're not going to need to buy another 500 another 100 nails because you're already at 400 at this point. So just bear in mind, if you're buying 400 nails, technically you're getting 500 nails because of that free 100. Now you need to buy another 50 nails, but there's no offer here because it just says only for every 100. So you're going to need to buy 400 nails to actually get 500, but we're going to need another 50 nails because in total that would actually be 550 nails, so we need to buy 450. So we need to buy 450 nails, and we know that 25 nails cost £2.95, but we only need to buy 450 because we get 100 for free. And what we've got to see is how many 25s go into that. 4, 16, 18. How many go in? 18 times this by 18. How much monies? 4. Damn it. What's going on? We good? We good. £2.95 times 18. £53.10. Right, so £5.50 there. It's going to cost you £54.78p from the nail company, from the hammer company. Ironically, the one which does not have a nail on the title is cheaper. 550 nails will cost you a price of £53.10p, which is cheaper. So we are going with the hammer company. Okay, so the equation x cubed plus 27x equals 90 has a solution to an answer between 2 and 3. Use trial and improvement to find this. Right, so when we put x in, it's going to pop us out an answer. Right, and we want to know firstly, is that answer going to be too low or too high? So low or high. And what number it is, if you want to be super precise. Question mark, you can if you like. So a number cubed plus 27 times that number, which is just there. It's going to be 90. We know the answer to this has to be between 2 and 3. It says give your answer correct to 1 decimal place. Now we've got to think about it. If you've got a decimal, it's like, you know, you've got 20 decimal places, say. When you're giving it correct to 1 decimal place, you have to come all the way down to the 2nd decimal place. So for instance, right now, because that's really complicated to think about. You got this massive thing going on. Whoa! Put a 4 that's for the banner. Now, give your answer correct to 1 decimal place. So essentially, if I highlight these two, which are the ones of interest, it's actually this one, which would then round the answer correct to 1 decimal place here. So we need to go as far in our answer as 2 decimal places in terms of investigating this, to ensure that we get all of the marks. If we only go as far as 1 decimal place it's not actually giving your answer correct to 1 decimal place. You need to investigate all the way to 2 decimal places, because technically when it rounds it to correct to 1 decimal place. That's what it's saying here, but it could be easily misread. So let's try 2. God, again with the blue pen. Why do this to me? Right, 2.1. So I'm going to try 2.1. $65.961, which is clearly much smaller than that's well too low. Let's go for 2.4. I want to go a bit higher. Oh, why did I do that? Again, I just cleared the calculator. Little trick here. Press answer equals. That was the answer. If I press up here, it pulls up my previous calculation. That's so much easier, because now I'm just going to press left, and I'm going to go back in. I'm going to put 2.4 in, like I said. 2.4. It is still too low. 2.4 is still too low. It's 78.64. 78.624. I'm going even higher. I'm going for 2.6. Oh, I've just done it again. Answer equals. Press back up. Sorry, it's been a long day. 2.6. 87.776. 87.776. Now that is getting super close. It's low. We tried 2.6. Let's now try 2.7. We're getting there. Left. Yes, I didn't delete it this time. Always learning, eh? 92.583. It's too high. 92 point. Now I need to investigate. Is it 2.6 or 2.7? What one should the 2 decimal places round to? What one is it actually closer to the solution? So now I need to go to say like 2.64 and 2.66. I'm not going to 2.65 because it's halfway between the 2 numbers, but you could. That would round up to 2.7, but it's technically halfway between the 2. So I'd just like to go 0.4 above 0.6 and 0.4 below 0.7. Or 2.7 and 2.6, should I say. So if I go here, 2.64, because that correct, 1 decimal place is 2.6. Oh, didn't do the one on the end as well. Mustn't forget that. 89.679. 89.679. A little bit low. 2.66. Probably going to be a little bit high. Maybe. Just a guess. Might not be. 90.64. That's enough actually there. I could go another decimal place. 1. Too high. Now, if you just have a look between 2.64 and 2.66, this here, away from 90, is 0.321. You could just do 90 subtract if you want. And this one here, it's 0.641. You can see that this one is actually much closer to 90. 2.64 is, in fact. So 2.64 is closer to the answer 90 than 2.66 is. Now, if you think about it, this rounded correct 2 decimal places is actually 2.6, whereas the one below is actually 2.7. So 2.7 is not the correct answer to the, well, the correct solution to solving this cubic equation here. It's actually 2.6. That's the one correct to 1 decimal place, which gives you the best approximation to this solution by trial and improvement. So 2.6 should be our solution. Correct 1 decimal place. Question 10, the diagram shows a trundle wheel. For those who don't know, that's the thing that you push along the floor to measure. Oh wow, it says it on the line there. Trundle wheels are used to measure distance along the ground. I've used one of these before, mine was rubbish. Don't buy cheap. The radius of the trundle wheel is 20 centimetres, right, worth putting on air. 20 cm, radius, middle to the edge. Jim wants to work out the distance between 2 junctions on the road. Right, so we've got junction 1, we've got junction 2. And he wants to work out the distance in between. And he rolls the trundle wheel between the 2 junctions. Good start. The trundle wheel, it rotates 34 times. So if you think about it, if you've got your trundle wheel, it spins round that times 34, that distance. So if you was to unravel it, sort of look like a straight line, wouldn't it? If you cut the top of the circle, fell down. That times 34. What's that distance though? The distance around the edge of a circle. That's what we call the circumference, which is pi times the diameter. Needs a diameter. We've got the radius. The radius is 20 centimetres. The diameter therefore is double the radius, which is 40. We need to do c is equal to pi times 40. However, that's the circumference for just one circle, but we want to see what 34 of them will be. So if we do, if we write, so the distance is going to be equal to, it's going to be 34 lots of the circumference. I don't need to calculate what pi times 40 is. Get it into a decimal, then times it by 34. It's fine just to put in one line. It's actually a lot neater. So can I leave it like this, or does it ask me to do something? It said, give your answer in meters, correct the nearest meter. So firstly, what unit am I working with here? So this was centimeters. So this is centimeters because I just doubled 20 centimeters to 40 centimeters. If you're rolling centimeters round, it's still centimeters. So this is in centimeters. So once I get this, if I do 34 times pi times 40, got an answer of 1,360 pi, which is 4,272.5. We could write that down, 4272.5. 4272.566. 0.566. 009. That's in centimeters. Now into meters we need to divide by centimeters, which is like century. 100 years is 1 century. We need to divide by 100. The decimal place back twice, or if you want to do it on a calculator, and divide by 100, not 1,000, 100. 42.72566. 42.72566 meters. Give you. Oh God, what am I doing? Give your answer in meters. Correct to the nearest meter. Correct to the nearest meter. Correct to the nearest meter. Well, the 7 there. We'll round up the 2 in the 1s, which is going to be 43. 43 meters. Looks like a decent size between the two junctions, for whatever it's worth. Okay, I'm seeing 2 right angled triangles here. I'm seeing missing sides. I'm thinking, Pythagoras or trigonometry. If the problem just involves missing sides and you have 2 other sides, you can just use Pythagoras' theorem. If it involves missing sides and missing angles, let me say that again. If it involves an angle and a missing side, or 2 sides to find a missing angle, so something to do with an angle and a right angle triangle, you could then apply trigonometry there. However, from what I can see, it says here, work out the value of x. We've got some information here which is telling us about the dimensions and the angles on these triangles. Work out the value of x, which is this one. Now to work out the value of this x, you can imagine it's sort of 2 triangles here. We've got that one. Okay, and then you've got the one below it, like that. If we could work out this length, we have this one, so we won't call that x because the other one's called x, that's just a little bit confusing. Let's call it y because it's close to x in the alphabet. If we could work out this one, we could then use Pythagoras' theorem to find out the missing side here. And actually, for the top triangle, we have this side, and we could find out that missing side. Now, for Pythagoras' theorem, if you recall, it's a squared plus b squared equals c squared, where c squared refers to the longest side here, which is c, which is also the hypotenuse, the one which is not attached to the legs of the triangle. So, if I call this triangle 1, and I call this triangle 2, let's work on triangle 1 over here. So we say that a squared plus b squared equals c squared. Let's label our sides a, b and c. So I've got my a, 5 squared, don't know what b is, of course leave it as b, and we've got c, which is 10 there. Let's rearrange this to get b on its own. So move that positive 5 squared to the other side. So subtract it. So you're adding it, adding 5 squared, and then move to the other side, subtract 5 squared, and then the opposite of squaring there is square rooting. Taking the positive solution for b, there's two answers to your square root, because obviously b's a length, so you can't have a negative length there. B is the square root of 10 squared minus 5 squared. Notice I am not putting this into the calculator, I am not getting a decimal, and I'm not tempting myself to then round that decimal and use it in my answers further down the page, because when you round a decimal, you are creating a, yes, easy to use decimal in the fact that it's smaller to write and easier to read, but you are rounding it and making it more inaccurate. If you then get that inaccurate answer and you use it in your working out down below, it's then going to be inaccurate answer being multiplied, being times, being divided, creating more and more errors across your work. So make sure you just leave it as it is for now. It's just a number. The square root of 10 squared minus 5 squared is just a number. Right, so we've got that missing side. Now, if I draw triangle 2 here, triangle 2, draw a little sketch just so it makes sense to me. This missing side was the square root of 10 squared minus 5 squared. If you think back to this green arrow, linking it down. We know this side is 4 from over here. And we want to find C, which is the longer side, opposite the right angle. So, in order to find that, a squared plus b squared equals c squared, where c is the longer side, A, I'm going to call this one. B, I'm going to call this one. Doesn't matter what way around they are, due to the commutative law. So a squared, I need to square the square root, effectively cancelling it out, but we won't worry too much about the algebra right now. Plus b squared, which is 4 squared, which yes is 16, but I'll leave it as it is. All I need to then do is square root my answer. I'm not trying to do any fancy calculations here, I'm just writing down the operations, and I can let the math speak for itself when I put this into the calculator. I'm trying my best not to create errors, so by keeping things as they are and not evaluating what the square root of 10 squared minus 5 squared square rooted then squared is, which is actually 10 squared minus 5 squared, and not evaluating that 4 squared is 16. I'm just leaving it as it is. There's nothing wrong with that. Now I need a square root in there, so this is 10 squared, so that was the small side. It's minus 5 squared, be careful there. Now I'm going to square this, as it says here. I'm going to add 4 squared to it. My answer, square root of 91. Can I leave my answer as a surd, which that's called? It says give your answer correct to 2 decimal places. So I could write here root 91 to ensure that I get another method mark. Give your answer correct. I'm just running out of space here. Correct to 2 decimal places. So 9.53. The 9 around the 3 up. This will become 9.54. 9.54. Now, I could check that that answer seems okay because it's meant to be the longest side. This one's 4. I could put what the square root of 10 squared minus 5 squared is in my calculator and double check that that's smaller. This is just a check for yourself. Is smaller than 9.54, which it is, so I know the other two sides are smaller, so it's just a good check there. So now I haven't done anything wrong. Question 12, we're talking about inequalities here. N is an integer, whole number, right? Keyword, whole number. It's whole. Right, write down all the possible values for n. So it says here, n is bigger than or equal to negative 2. So the next whole number up, so it's bigger than, sorry, or equal to negative 2. So it can be negative 2. It can be bigger than it, so the next whole number is minus 1. Bigger than that, 0. Bigger than that, 1. Bigger than that, 2. It says that n is less than 3 though, so I'm not allowed to put 3. Of course it had the inclusive inequality sign like that, I could, but it doesn't here. So I've got 5 values and it's 2 marks. The reason why this is because students can tend to miss this one, or they can tend to include that, but they still may be awarded 1 mark for including the rest of the values. Solving this inequality. Solving an inequality is just like solving an equation, except if you divide or times by a negative, you must remember to flip the sign round. The inequality flips around, it reverses direction. For example, 1 is smaller than 2. True, but if you times both sides by a negative, i.e. negative 1, is negative 1 smaller than negative 2? You need to make sure you flip the sign. Right, so just something to remember. So I'm just going to solve it like a regular equation, right? So I want to get the x's on one side, I want to get the numbers on the other eventually. So firstly, let's move the x's across to one side. What's bigger, negative x or 2x? Well, 2x is bigger. I'm going to bring that across to the other side. I'm going to add x to both sides. Do the opposite because that's subtracting x. I get 3x there now. 2x add x is 3x. If you were to take 2x across to the other side, you would end up with negative 3x. Let's not do that. I'd rather not work with negatives just because I don't really like them too much. Let's move this negative 5 across to the other side. So add 5 to both sides, do the opposite. 9 is smaller than 3x. And then the last step, move that times by 3 across to the other side, divide by 3. 9 divided by 3 is smaller than x. 3 is smaller than x. AKA, I want all the values of x which are bigger than 3 would satisfy this inequality. For example, if I was to pick, let's say, the next integer, x equals 4. If I put this in this inequality, it'll be true. For example, 4 take away 4, it's the x, is less than 2 times 4 subtract 5. 4 take away 4 is 0, which is smaller than 2 times 4, which is 8, subtract 5. 0 is smaller than, what's 8 subtract 5? 3. 0 is smaller than 3, is that true? Well, I hope so. Yes, it is, of course it is. So, if I was to pick that x is 3, or x is something which is not bigger than 3, this inequality wouldn't be true. And that's something you can investigate yourself if you like. So we just need to have that x is bigger than 3. Next one, 13. The value of an investment increases exponentially. That means it goes, because it's increasing exponentially, so it starts slow and then boom, just goes straight up like this, sort of like in a very small amount of time. Or you can get exponential decay where something is going really fast, it's decaying and it starts slowing down. That's what exponential growth or decay looks like. Okay, so you've got your investment, it's increasing exponentially each year. Yes, your investment's increasing exponentially, you're getting lots and lots of money with a multiplier of 1.15. Now, something to bear in mind, investment. It's equal to, it's saying it's multiplied by 1.15. Right now, things which have exponential growth generally look like this, where a is a constant, or just it's just a number. For example, y is equal to 2 to the power of x, y is equal to 3 to the power of x, y is equal to number to the power of x, something. But when you have something to the power of x, as x is increasing, so if you think about this, 2x, now let's actually go a little bit larger so you'll be able to see the growth. 4x or x to the 4. If I say x is 5 here, that would be 4 to the power of 5 versus x is 5 here, 5 to the power of 4. Which is bigger, 4 to the power of 5, which is 1024, or 5 to the power of 4, which is 625. This one's bigger because this one grows much faster. When you put x as 10, 4 to the 10, that's much bigger than 10 to the 4. So it's really worth noting that, just understanding that this is what exponential growth looks like, equations of this form. So it's increasing exponentially with a multiplier of 1.15. So that's our number, that's our constant if you like, and then each year, so it's increasing exponentially each year with a multiplier 1.15. So how long does it take for the investment to double in value? Well, if we say that this part is the number of years, well, when you first put your investment in, that's no years have gone past. X equals 0. No years have actually gone past. Initially, some of you may know this just by looking, it's 1, but after a year, the amount we have, so when we first put it in, our initial investment was 1. That's what it says here. Our initial investment was 1. That's the initial. That's your starting. We want to double this. We want to get 2 times the investment. So let's try 1.15 to the power of, say, 2. Let's see what happens after you've put it in and it's been in there for 2 years. We want to double the investment from 1, obviously, up to 2. 1.3225, not quite. Let's try 3. 1.5, not quite. It's climbing. 4. 1.74, no, not enough. After 5 years. Oh, okay, after 5 years, it's finally just over doubled. So if we just pull those two important parts down, 1.15 to the 4. The answer to this one was 2.01, 2.011, and the other one, if I press up, remember, replay function, press up, press down, press up, press down. Right, 1.749. 0.749. Now, of course, after 4 years have elapsed, it's not quite doubled in value, but after 5 years have elapsed, so that's, remember, at the end of the second year here, that was the value. At the end of the 4th year, that's the value. After 5 years, it's now doubled in value, so it's taken, correct to the nearest whole amount of years, because it's actually 2.011, so somewhere in the 5th year, maybe midway through, maybe, you know, in July rather than all the way at December, because at December it's over doubled just by a small bit. So to the nearest whole year, it's happened in the 5th year. We don't know where. It could have been somewhere, but it's happened in the 5th year. 14. Oh, right. Okay, so now we've got some for 14A and 14B. We've got some solving equations here. Solve the following equation. Now, I'm going to put this line there for working out for those who haven't seen this. Now, currently, what's happening to x squared? Well, what's happening to x squared? What's happening to x? We're squaring it and we're timesing it by 3. If we divide both sides by 3, x squared equals 49. 147 divided by 3. Yep. What's the square root of 49? I'm going to make the easiest mistake in the world. Ready? The square root of 49, and I'm going to get 1 mark here for this. I'm going to get 1 mark. Maybe, depends how they are. I personally think there's 2 answers. What's the square root of 49? It's 7, or is it minus 7, or negative 7 should I say, times negative 7. 49 also. Yeah. Yeah. Right, so square root there. So square root of 49 is plus or minus 7. So you've got positive or negative solutions. It's 2, because remember, quadratic graph looks like that. 1 there, 1 there. Where the roots are, that's what you're actually effectively finding here, is where it crosses. So solve the following. Let's get a common denominator. 2 and 3 will both go into 6. So if I times this one by 3 and I times this one by 2, that'll be good. Times 1 by 3. So times every term on the top by 3. This left hand one here. Dot dot dot. 3y subtract 3 over 6. And of course the bottom. What you do to the top of the fraction, you do to the bottom when you create an equivalent fraction. And then times the second one by 2. We said here 2y plus 2 over 6. 15. We've got a common denominator, so you can just add the numerators. I'm just going to bring them together on one line. So 3y plus 2y plus 2 all over 6. So that looks a little bit nicer now. And then we can times both sides by 6 to get rid of that division. 15 times 6, 90. You're going to have to trust me on this one. Oh god, I don't even have to trust myself. Yes, 90. Whew. Now bring your y terms together. So we've got a 3y and a positive 2y, so that makes 5y. We've got a negative 3 and we're adding 2, which is negative 1. Let's add 1 to both sides to get that negative 1 over. 91. And finally we want to divide 91 by 5, which is 18.2. Okay. 91 divided by 5. For those of you who wanted to know how I done that, it's on the other video on my channel. Right, 450,000 in standard form. In standard form, you need a number which is between 1 to 10. Not 1, not 10, but in between. And it's times to 10 to the power of something. Something. That's how you represent a number in standard form. This number is currently not in standard form. If I wanted to move this in standard form, I need to move the decimal place about once, twice, 3, 4, 5 times. It will become 4.5 times 10 to the 5. Just to check. If you clear that decimal place once to the right to make 45, and then move it 4 more times to create 4 zeros, that'll be correct. Right, that's my tactic as to how I do that. And obviously check it on a calculator. 4.5 times 10 to the power of 5 is indeed 450,000 without the comma or without the space. Write this as an ordinary number. Well, I've got a calculator, so do you know what? I think I might just try and do this first of all, see if it works. It doesn't. You can switch modes to be able to do this, but I don't think it's worth showing it in this video. Just worth checking that first of all. But what this essentially means is, as you can tell, when it's a positive power, the number is getting larger, right? When the number is a negative power, it's getting smaller. So rather than moving the decimal place to the right and creating a much larger number, we're moving it to the left. 4 times to the left. So once to clear the number to become 0.32, and then we need to go another 3, so it'll be 0.00032. And just to check it, this is what I always like to do, I should have moved 4 decimal places in total. 1, 2, 3, 4. Between the 3 and the 2, as it originally was here. So 0.000, and it is a small number. Work out this. It's a cube root. For those of you who don't know, hidden on your calculator is the cube root button behind the square root. And in fact, hidden behind x to the power of something is a button where you can find the root of whatever you like. I could click on this, I could put a cube there. I could find the 5th root, I could find the 7th root. But indeed, I'm finding the cube root. I could then put my number in there. Alternatively, shift, press this button behind the square root, it's already there. Now, 6.4 times 10 to the power of 10. How many marks am I getting for this question? 1. Because I need to round it. 4,000. Nice whole number. Make Q the subject of the formula. That means I need to get Q on its own because currently R is the subject of this formula. So, times it by 3. 3R equals 2Q subtract 4. And next thing, move that negative 4 across to the other side by adding 4. 3R, add 4 equals 2Q. Last step, do the opposite of timesing by 2, divide by 2. 3R plus 4. All of that divided by 2. That's what Q is. It's the subject of the formula. Yes, it's on the right hand side. No, it's not the end of the world. You could also swap it round like this if you so wish. Okay. On the grid, draw the graph of y equals 1 over x for values of x which is going from 1 to 7. So I want to look on my x-axis. I want it to go from 1. I want the portion of the graph, whatever it looks like, however funky. I would not want this part here, the ones which is smaller than 1. I'm just looking for the portion of the graph which is between 1 and 7. That's it. So, how can I do this? You might have a way. I like my way. It's as follows. How to plot any graph. Mode. 3. Table. This means y. Y equals, I want to do 1 divided by x. X is there. It's red. Alpha for the red. X equals. I want it to start from x at 1. I want it to end at 7. I want it to go up in 1. So that's 1, 2, 3, 4, 5, 6, 7. In total, I have 7 coordinates. When x is 1, y is 1. It says here, when x is 1, y is 1, right? So x, y, getting a table of values. This always gets you a mark. 1, 2, 3, 4, 5, 6, 7. 1, 0.5, 0.5, 0.33. Recurring, which is a third. Keep coming down. 0.25. When x is 4, this is 0.25. I might actually do this because it's going to get a little bit messy, I think, in my opinion. That's the worst table I've ever seen in my life. Do not copy that. 0.25, 0.25, 0.2, 1.666 recurring, which is 1 2/3, which doesn't make sense because the numbers are getting smaller. So what have I done? Because it's 0.166, silly. God, can't even read. 666. Last one. 0.7. Sorry, for 7, the answer is 0.1428. 0.1428. Right, I'm going to give my best attempt to plot this. So, when x is 1, y is 1. Tick. Because when x is 1, please go off my page. x1, y is 1. Right. When x is 2, down here, y is 0.5. When x is 3, y is 0.33. When x is 3, y is 0.33. That's 0.3. So that's 0.32, 0.34, 0.36, 0.38. Yeah, it's going up in 0.2s, or 0.002, 0.3, 0.32, 0.34 is just about there. Come on, pen, please be accurate. Yeah, that'll do. Okay. Tick tick. When x is 4, y is 0.25. When x is 4, y is 0.25, 0.2, 0.22, 0.24, 0.26. There, just in between. 5, 0.2, 5, 0.2. That's a nice one. Please give me another one like that. 6 and 0.166. 6, 0.1 is here, halfway between 0 and 0.2. 0.12, 0.14, 0.16, 0.18, so it's about in between. A little bit above that. That'll do. And 0.4, 0.1428. Christ. 0.1, 0.12, 0.14, just about there. Right. Now this is what do you call a reciprocal graph. So you want a nice smooth curve. It does not look like that. So your points you want to join smoothly together. Do you want to go back or yeah? That'd be nice. Rub you out. Okay, so join them smoothly, smoothly, smoothly. It's a good idea to ensure that these are crosses in future, and you can see why. Because I missed the coordinate, I don't even know where it is. When x is 3, it's 0.333, which was like there. No, it was there. Doing it across in future, so obviously the line doesn't consume it. But yeah, now you can see that the portion of the graph, it does not go below 1 here, and it does not go above 8. 3 marks, putting it into a calculator and plotting the points is quite nice. Solve this quadratic equation, which is of the form ax squared plus bx plus c equals 0. Now, do you, on your formula page, this is where it freezes. I'm going to go slowly. Oh my god. I am going to assume it's on the formula page because I'm not crashing this after all this time. Sorry. Okay, so to find out the solutions to a quadratic equation of this form, i.e. the one which I'm just putting here, it's minus b plus or minus the square root of b squared minus 4ac. This bit's called the discriminant under there if you didn't want to know. Oh, if you did want to know. 2a. So a is 2, b is positive 4. Don't know. I'm writing the positive there, and c is negative 5. A, b, c. Give your solutions correct 2 decimal places. Solutions, plural, 2. 2 solutions. When I put it in the calculator, I use the positive one and then the negative one, or the negative one and the positive one. Depends how you're feeling. I'm going to go positive and negative because why not? Now, x is equal to negative 4, that's the b, plus minus b squared, that's 4 squared, minus 4 times, I'm going to put brackets there, I don't like using times here, the actual multiplication symbol, ac, so a is 2, c is negative 5, and this is all divided by 2a, 2 times 2, could have put 4 there but just didn't. So let's have a look. Mode, put it back into computation mode just for general calculations. Now, fraction, okay, fraction, negative 4 plus, I'll go for first, I'll go for the positive. In my mind it's positive. The answer might not be positive though. That's just me trying to be positive, if that makes any sense. Negative 5. Oh, is there a space there? No, there's not. So that means multiply because they're touching. They're adjacent to one another. 2 times 2. You could put multiply there if you want, but I like it like this. So, it's actually minus 2 plus or minus the square root of 14 over 2. That's just tidying it up a little bit, rather than having the square root like that. And it's cancelled down here. So this square root in front of it, when you evaluate it, it's going to have a root 4 which then is 2, and this left term, bottom term, and this right top right term will have a factor where you can cancel 2 down, hence why that's been cancelled. Now, one solution, which we'll call x1, subscript, that's notation. It says give your solutions correct 2 decimal places, 0.87 here, because the 0 keeps it the same, doesn't round it up or 0.7, x2, which is minus 2. That one we went for the positive one first, so scribble that little one out. Ooh. Subtract. What is our negative solution if we see the negative sitting there? Negative 2.87 and the 0, keep it like that. There's your answers. X is that and that. And I say and because this graph looks a little bit like crosses at 0.87 and negative 2.87 and that's a negative 5. Looks a little bit like that, where this point and this point are there and there. 3 marks. This sighi. I'm going for the sine family. The sine family and the Peterson family go to the cinema. Wild day out. The sine family buy 2 adult tickets and 3 child tickets. 2 adult tickets, 2x, x for adults. And then we're going to go for y for the children. Or child. 3 child tickets. 3 children. No, 3 child, yeah. 3 child. Okay, right, so they buy that. They pay £28.20. That there is much easier to read for me than this piece of information. The Peterson family buy 3 adult tickets and 5 child tickets. They pay £44.75. Oh, we've got simultaneous equations. Find out the cost of each adult ticket and each child ticket. Well, already just by writing it like that, you can see straight away it's formed 2 simultaneous equations. 1, 2. Strategy here, let's make the x's the same or the y's the same, it's up to you. The way you could do this, if you are to multiply first equation by this leading coefficient, which is 2, and multiply the second equation by this leading coefficient, which is 2, multiply the first equation by the second equation's leading coefficient, which is 3, i.e. equation 1 multiplied by all the way across 3, and equation 2 multiply by all the way across. This should create a common coefficient. Coefficient is a number in front of x, or number in front of a letter. 2, which is times the amount by 2, diagonal. Okay, so let's multiply the whole equation 1 by 3. 6x plus 18y. £28.20 times 3. Oh, 60. 84.60. 2 multiplied by 2, so 3x multiplied by 2 is 6x, 5y multiplied by 2 is 10y, 44.75 multiplied by 2 is 88, add 150, £89. £89? Yeah, £89.50. Right, now I'm just double checking my calculations, it's getting late. Mistakes can happen. That times 3 is 6, yeah, that times, equation 1 times 3. I multiply 3 by 3 and get 18. That is a new one, if I've ever heard of it. 3 times 3 is 9. But did I do £28.20 times 3 successfully? If I did, but I can't do 3 times 3, that's weird. That's really weird. £84.60. Yeah, I got that right. How does that make any sense? Right, equation 2. Multiply that by 2, times that by 2, yes, times that by 2, yes, times that by 2. I'm guessing £44.75. When you multiply it by 2 is that. Being as I got the other one right, £89.50. Okay, not made any more silly errors. Step 1, check it. Always check it. Don't forget, check, check, check. Now, what I'll do here is, so if you think about this as like equation 3 and this one is equation 4, I'm going to do equation 3 subtract 4, simply because that's going to be 10y subtract 9y, as opposed to doing 9y subtract 10y and creating a negative. Doesn't matter if you do though, it will still work out the same in the end. So I'm putting a subtract in between these because I'm subtracting, and I'll just put this arrow here just to show very clearly how my mind process is working. Yeah, that made sense to me. 6x take away 6x, gone. 10y take away 9y. 1y. £89.50 take away £84.60. £4.90. But I'm checking it because 100%. Take away £84.60. £4.90. Good. And then I'm going to substitute this value into either equation 1 or equation 2. You could put it into 3 or 4, but they're scaled up, so the numbers will be larger. I'm going to pick equation 1 because it looks like the numbers are generally smaller to work with. So I'm going to sub, aka substitute, £4.90 into equation 1. So I'm going to write it out. 2x, oh, the blue pen again. Christ almighty. Will you just go away? Back to black, yes. 2x plus 3 times, I'm going to put it just one more line just to make it super crystal clear. Put in y as £4.90 into there. 2x plus 5, 15, take away 30, £14.70 equals 28.20, and then I'm going to solve it. So subtract the £14.70 from both sides. Do you know what? I'm checking it. I'm doing it. Good. 2x equals, and then £28.20, subtract £14.70, £13.50. You know what? I'm checking it. I'm doing it again. £28.20, subtract that, and which took my previous answer, £13.50. Last step is to divide it by 2, because I'm multiplying by 2 here. Divide by 2. And £6.75. Yes, £6.75. Right. X equals £6.75. Job is a good one. I think the calculator's going off the screen a little bit. I think that's good. Okay, so last thing. Yeah, do you know what? I want 4 marks on this. So I've used equation 1 to sub it back into. I'm going to check in here. 3x, so check. Writing check doesn't get you any more marks, by the way. At this stage, everything's been awarded if I've done it correctly, but I'm just checking. 3 times my x value plus 5 times y should give me £44.75. That's what I'm looking at if I've got the correct numbers here. So 3 times, oh god, it's blue again. Do I keep looking at that? 3 times 675. Add 5 times y, where y is 490. 5 times 490 should be giving me that value. 3 times, if not, I've made a mistake somewhere. Well, the calculator's wrong. Probably me though. Should be £44.75. Yes, if I would have made a mistake there, I'd just ran through my working out one more time to check that I didn't do 3 times 3 and get 18. Something like that. But yes, tick. Check's right. So that's 5 marks there. That's a lot of marks. 20. It's never ending. The volume of a sphere is 70 centimetre cubed. Right, unfortunately, I cannot remember for the life of me the volume of a sphere, but I do know that it was at the top of the formula page. So the volume of the sphere is 70 centimetres cubed. Calculate the upper bound for the surface area of the sphere. Right, so I need the surface area and I need the volume. I'm going to do this and it's going to crash. Don't do it. Don't crash. What if I rush? Yes. No. Yes. That's nasty. No added sugar. Right. Volume of a sphere is 4/3 pi r cubed, and this is 4 pi r squared. Now, earlier when I tried to screenshot and then add it in to OneNote earlier, that didn't work, so I'm going to remember this. 4/3 pi r cubed. So both got a pi. So 4 pi r squared. If I add 1 to that power, it becomes 3 divided by it. Okay, 4 pi r squared. Got it. 4 pi r squared. 4 pi r squared. 4 pi r squared. 4 pi r squared. I'm aging. I'm going to have greys by the time this finishes. 4 pi r squared. Hey, surface area. 4 pi r squared. Volume. The r had one more, and the 4 is divided by that number. Good, got my stuff. Volume of a sphere. Always look at the formula page because of that. Volume of a sphere is 70 centimetre cubed, corrected to the nearest centimetre cubed. So it's been corrected, so it's been rounded. So it could have been 70 point, not 5 because that around 71. It could have been 70.4. It could have been 69, lol, it could have been 69.5 because that's still around 70. So anywhere between them. Right, calculate the upper bound. So chances are we're going to use this one, which is a higher value. However, when you're looking at upper bounds and lower bounds, you actually consider, you got your 70. How the bounds are actually wrote is as follows. So we had our 69.5. All the answers, all the numbers you could have, all the ones bigger than 69.5, so like 69.6, 69.7, 69.8, and everything between those, all the way up to 70.5, because of course that will round up, but that's your upper bound, and that's your lower bound. So my upper bound is 70.5. I'm probably going to be using that value in here. Calculate the upper bound for the surface area of the sphere. So I need to get the surface area of the sphere. So I'm going to need 4 pi, that's just a number, it's like 4 times 3 roughly. I need r squared to work this out. But what have I been given? I've been given the volume of the sphere is 70 centimetre cubed. I'm going to go ahead and assume that's that, 70.5. But I'll keep it at 70 for now. So the volume, that's number 2. So number 2. 7 equals 4 over 3 times pi, which is 4 over 3 times pi is just a number. Again, just a number times pi r times r cubed. Well, just a number, which for those of you who do not believe me, 4 over 3 times pi. It is just a number, an infinitely long number. So I'm going to keep it as 4 over 3 pi because I like things simple. In the opposite of timesing by 4 over 3 pi is dividing by 4 over 3 pi, which is completely okay to do. 70 divided by 4 over 3 pi is equal to r cubed. Now this is really useful because I want to get r squared. So if I cube root r, that funky button on the calculator I showed you earlier, if I cube root this, I'm not going to work this answer out and introduce an error, and even then this 70 potentially could be 70.5. We'll talk about that in a second. Right, now we want to work out the upper bound of the surface area, so to bear that in mind. Now I've got r, I need to, for the surface area, so if I do this over here, the surface area is actually 4 pi times, well, the radius squared, which r stands for the radius here if you didn't know. That's this value, which is the cube root. I need to get this, I'm going to put it in a square bracket. You can put it in a regular one if you want. Don't know why I actually did that. 70 over divided by 4 over 3 pi. Yes, it's slanted, it's fine. That squared. So this here is r squared. Right. So all I need to do at this point is put this into a calculator, but with one last thing. So this r, as I increase, if you think about this for a sec, so I need to work out what am I doing? Am I using 70.5? Am I using the upper bound or the lower bound here? Because it's been rounded, what am I going to do? Think about this. This is a fraction here, this part. If I have a fraction, let's look at a basic one. So 5 over 2. As I increase the number on the top, what happens to the value? So this goes 2.5 to 3 to 3.5. The larger the number on the top, when the one on the bottom is fixed, the larger the outcome. And we want to work out the upper bound for the surface area of the sphere. We want this here to be the biggest possible value it could be. Well, 4 over 3 pi, just a number. That's just a number, just like 2 here. Obviously not the same value though. Now, I don't want 70, I want it to be the largest it could possibly be. So actually I want to use 70.5 here. So that here just help me do a little bit of analysis to double check that I should have a 0.5 there. I want the largest possible outcome. So the surface area is equal to this, which there's no decimals occurring yet. It's just as it is. 4 pi. 4 pi times, and then we've got square brackets on here. Cube root of 70.5 over 4 over 3 pi. Oh, don't want that. Press right again. And then remember it's r squared for this, but that's not worked out very well, has it? Right, right. Well, that's gone left. Right, to get really far out of it, get it there. I'm going to square that because that's our. It is 82.52968785. I would write down the whole calculation, but I'm running out of time. So it says here, give your answer correct to one decimal place. 82.5 at the 2. We'll keep that the same. So it'll be 82.5. 2.5. Next question. Vectors. Right, my class, you haven't seen this. I'm teaching you this tomorrow, so this is strange, but I could teach you anyway. A vector like this. This is A. If I have a vector, it's got something which has got direction and size. So this is a vector. If I was to double it, that would be 2A. Worth noting. This vector over here is also A. It's parallel. It's meant to be exactly the same as the other one. They're both A. If I reverse the direction of this arrow, it's exactly the same. Length, pretend it's the same length. I know it's a bad drawing. That'll be negative A. Just worth noting. So if you have a look on this diagram, this one here is A, that length. It's a regular hexagon. Regular. So all of the sides around the outside are the same. And these are equilateral triangles here. So this is the same as this length, which is the same as this length. All these lengths are the same. So this length is the same as this length, so that vector is the same length as that vector. They're both pointing in the same direction, so we can say that's A as well. We can underline that. That's normally what you do with A, or you need to make it bold, but it's quite hard to make one bold and not bold. So I usually underline it so it's a vector. B is the one in the vertical direction, horizontal, sorry. Now that's B. Now this one here is a little bit trickier, so we'll get to that. What else we got? M is the midpoint of OE. M is the midpoint of OE. Okay, there's M. N is the midpoint of AB. Where's A to B? It's there. N. Find MN. So MN with the arrow from M to N in terms of A and B. So if I'm to get to this here, draw out this little section just to explore it. Okay, that's kind of going down. Right, that's kind of like that. Yep. Okay, and then that'll be that. That's fine. So I'll keep that there for a second. I may use that. Right, so let's explore a few things. If I just take this off for a second, I know where I'm looking for. I'm looking for that bit. Just want to add a few more annotations to complete my diagram. That one was B, so I've added that. I've added that one's A. This one here is B, and then you can see there's like a little parallelogram here. Remember, they're all the same length, so as long as it's the same length and same direction, you can say it's the same vector. Come back. Right, that one is B because it's the same length and direction as that one. This one is A. I only really need to focus in that top left hand part, I think, except I need a little bit coming down here, so I need something to do with this part. Now if that's A, this one's A, remember these are all equilaterals, this one going down is the opposite direction. That's like negative A. Or it could be going the other way, and it could be positive A. Now, if I am thinking about being, say, here, which is N, all the way up, M, sorry, all the way up to N, what route could I take? Well, what I could do I could go up here, up there, up here. Or I could go up here, along, up, back. I could do a few routes. Now if I was to look at just say one route, I go up here. I go along there, up there, and back. If I'm to write this in, this one here, so that route, essentially, when I'm going across, we said that's B. When I'm going up, we said that's A. So I'm just looking at this part. We go back halfway along the B vector. It's going to be negative a half B. All I need to figure out now is this part. So if we have a look, rub all this out for a moment. Let's go back to our basics. What is this line here? Now I know this one is A, and I know that this one is B. So if I have a look at this problem over here, I haven't learnt this bit yet, so I'll try to take this a little bit slow. So that's B. So going from this point, God, there's the blue again, to this point, that's B, and going from this point to this point, that's A. Now, if I'm to go do the following, so if I'm to go down the opposite direction of A, so that's negative A, and then I'm to go along here, whatever that is, I end up at B. So I started at the end of B. Oh, no, don't do that. Oh, no. Work. Alright, I'm not going to break it. Okay, so if I just think about, I want to find out what we want to find out what this vector is going from here to here, because we was actually looking at the journey up here. Essentially, it's the same as going up here and then left. So going up A and then going back the opposite direction of B. That's essentially, I don't want to go into too much detail, I'll just check the time. That's essentially what this vector is called. It's the triangle inequality, we call that. So this one is actually A minus B, but we need to remember that we're not starting from here, we're starting from here halfway along this, which is a half A and a half negative B. So we've got these two parts. We've got our B journey here, which was that part. We've got our A journey, and we've got our going back, that's negative a half B. So in total, if I just look at the A's, I've got a whole A there, and I've got a half A there. In total, I've got 3.5. And for B's, I've got a negative a half B here. I've got a positive B. Oh, a whole one. So 1B, take away a half B. Well, one whole, take away a half. That's a half B so far. A half B, subtract, because we are negative there, a half B is essentially cancelling it out. We just get left with 3 over 2A. Describe fully what your answer. So part A shows about the lines OA and MN. OA and MN. MN. What relation does this green line have to the line OA? Well, if you look at it, OA was the A vector, and MN was the vector 3 over 2A. It's got nothing to do with B. And if you look at these two vectors, you might notice they're parallel. And actually, if this is 1A, that's 1.5A. The vector MN is actually 1.5 times the size. It's 1.5 times bigger than A, or than OA. MN is 1.52 bigger than A, and is parallel. Absolutely fantastic result. Really, really nice. Here's the graph, y equals f of x. Write down the coordinates of the point where the graph y equals a half f of x meets the axes. So we're shrinking it, right? So, write down the coordinates of the point where a half. So if we've got a graph and we are shrinking it, so if I'm to think about what this would be. In my head, I'd think, well, this is a straight line equation. Say, for example, this is crossing at -2. It's going to be something x subtract 2. To work out the gradient, I've got this here. Gradient, that is going down 2, and that's going across 1. The gradient, changing y, -2, I'm changing x. Graph is y equals -2, x subtract 2. You could do it like this if you like. I want to work out what a half f of x is. So if I'm to half this here, I get -x subtract 1. I end up with the graph here. And then this is the graph -x here. This is here. Going from corner to corner because it's got a gradient of 1 but negative. What happens there then? Right down the corners where the point meets the y-axis. Well, it is x is 0, but it's gone up by 1. On the grid, draw the graph of y equals f of x minus 1. Well, you think here it's going to move along left 1, but actually, in actual fact, it shifts across 1 to the right. Just to check, the original graph was y equals -2x minus 2. I'm assuming it's going to shift across 1 to the right, so just to double check how this is going, if you go along one little square up 2, so if I'm here, shifting along one up there, along one little square up 2, along one little square up 2, and then down one little square, oh no sorry, down 2, right one the opposite, down 2, right 1, and then you create your line, draw it up using a ruler. Such a good ruler what I'm using, right? Just to check this works though, so we want to investigate what happens when y is x minus 1 rather than x, so substitute x is minus 1 into here, y is equal to -2, x minus 1 minus 2, expand that bracket, -2x plus 2, positive, negative times a negative is positive, subtract 2, y equals -2x, and then what's positive 2 subtract 2, oh it's gone, you end up with y equals -2x, it's the same gradient as your original thing, so they're parallel, however, the intercept now is not a -2 anymore, which it was here, it's at 0, plus 0 or subtract 0, it's not there, which it is. So that's just a nice way to investigate that. And that's that paper. Hope you've enjoyed it. I know it's been long. I hope that you've learnt something. If I've gone through anything too fast, just drop a comment in the comment section below. God, I'm brain dead. Completely on brain dead. Right. Yeah, drop a comment in the section below. I have probably made a mistake somewhere. It's getting on quite late. Just make sure you just drop that below. Say, you know, Mr. Stringer, Moustache Mathematics, whatever you're going for, whatever alias it is. Just say, look, you made a mistake here. Please can you correct it? And then I'll try and annotate over the top, or I'll just upload a separate video just addressing that mistake. Other than that, best of luck with your revision. Make sure you revise for Thursday, please. And as always, Mr. Moustache Mathematics here. Signing out. I hope you have a good day. Like, comment, subscribe.